I only grow.
All
right. I get on like hairs over here, so that takes like 6 years. All right, guys. So we got a couple questions in the homework that are throwing some people off. We're just gonna start with something like this. It's gonna be like x to the 8th, and I don't really care what the rest of this is. But there are going to be, so it asks you to use Descartes' rule of signs. So remember what that means. It says but basically what we do is we take P of X and we count the number of sign variations, right? Okay. So if I'm going to count the number of sign variations, let's say for some reason I count the sign variations and I get positive, for my positive real zeros, I get, let's say, 6 sign variations. Okay? So that would be like x to the 8th. Let's just write one, I guess, be more specific so you guys can use this a little bit easier in your homework then. So that's 1. So then I've got to go, so let's go x to the 7th. So no sign change yet. So now let's go make minus x to the 6th, plus then x to the 5th, minus x to the 4th, plus x to the 3rd, minus x squared, plus x minus, let's say, 3. Okay? So let's just count the sign changes real quick. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6. Let's make that positive. So it's only 6 sign changes. Is that okay? Okay. So Descartes' rule of sign says count the sign variations. How many times you go from plus to minus or minus to plus in consecutive terms. Then you can have that many positive real zeros. But you could have less than that. But you can only have less than that by an even whole number. Okay? An even whole number. And the reason for that, if we were to dig into this and all that kind of stuff and details, has to do with how we have to cross the x-axis and how we have to end up modeling our end behavior. Okay? And then it jives with turning points and all that kind of stuff. Okay? So I could have 6, remove an even whole number would be 4, right? Remove another bigger even whole number would be 4 from 6, it gives me 2. And then remove 6 from 6 would give me 0, right? Now the way to come up with that list, I think, is easier than removing an even whole number. Is just say, okay, I'm going to start with whatever my upper amount is. My ceiling is 6 positive real zeros here. And basically what I'm going to do then is subtract 2 from that until I get down to 1 or 0. Okay? If it was odd, I'd get down to only a 1. If I start with an even number, it'll get down to 0. So that's how many positive real zeros I could have. Why is that nice? Because if I find in my list of P over Q's that I get 1 positive real zero, that list right there tells me I know I at least have 1 more positive real zero. Because I could have 2. Does that make sense? Nowhere up there it says you have 1 positive real zero. Okay? You're going to have that many. Okay? So if I find 5 positive real zeros through my synthetic division, I know that I'm going to have 1 more positive zero, and once I find it, I can stop looking at positive zeros. Does that make sense? I can just concentrate then maybe on my negatives. So the negatives, you have to look at P of negative x. Okay, so here, and I told you last class, that's my hope is, guys, that we don't necessarily have to do this. Now, the way I wrote this original P of x, maybe this is actually a good idea, because I didn't, no, I didn't put coefficients on here. So it might be kind of hard to keep track of where we're at. But a lot of this negative P of x stuff I think you can do in your head. And maybe you don't have to write down this row. For instance, if I look at negative, so P of negative x, I'm putting that in a negative x. I know negative x multiplied by itself 8 times is positive x, right? To the 8. Here, I'm going to have x, negative x to the 7th. Well, that's a negative. There's a positive out front, so it's going to be a negative x to the 7th, or minus x to the 7th. This is going to be a positive but there's a negative out front, so negative x to the 6th. This is going to be negative, and there's a plus out in front, so it's going to be negative x to the 5th. This is going to be positive, but there's a negative out in front, so it's negative x to the 4th. This is going to be negative, there's a positive out front, so it's going to be negative. This is going to be positive, but there's a negative out front, so it's going to be negative. And this is a negative x, and then plus 3. So now the question is, well, how many sign changes do you have there? There's one right there, it goes from positive to negative, and the rest of these stay negative to negative, right? Except for the end. So I have negative zeros could be 2, or remove a whole number from that, an even whole number, so 0. Okay? So they're going to ask you a couple questions here. Okay? They're going to ask you a couple questions. And we'll do 2 problems like this. They're going to ask you how many positive real zeros possible. There you're going to write 6, 4, 2, and 0. The next thing they're going to say is negative real zeros possible. There you write 2 and 0. Does that make sense? The final thing they're going to say is how many possible real zeros. So now we're looking at totals. Does that make sense? Don't care that they're plus or minus. We're looking at totals. So if I had 6 positive real zeros, I could pair that with either of those. Does that make sense? So if I pair 6 positive real zeros and I had 2 negative real zeros, how many total real zeros would you have had? 8. Okay? If I had 6 real zeros but 0 negative real zeros, how many would I have? 6, right? Okay. If I had 4 positives paired with 2 negatives, I would have 6, right? I already got 6. But 4 paired with 0 would give me 4. 2 paired with 2 would give me 4, but 2 paired with 0 would give me 2. 0 paired with 2 would give me 0, and 0 paired with 0 would give me 0. Does that kind of make sense of how many possible real zeros I can have? Okay. Now, here's the thing. So why can't I have 7? Why can't I have 5? Why can't I have 3? Why can't I have 1 possible real zero? And the reason for that is what we're going to learn in section 3.5, basically saying if you have 6 possible real zeros, then you have 2 non-real zeros. Does that make sense? Okay. Because what was our leading term in our polynomial? X to the 8. So we're going to have 8 factors. Okay? But if only 6 of them are real zeros, the other 2 are non-real, or what we refer to as imaginary, right? A plus BI form. Okay? If I have 4 real zeros, then the other 4 are imaginary, complex. If I have 2 real zeros, the other 6 are complex. Does that make sense? Okay. So there's one question. I don't know if everybody's getting it, but there's one question on that. Let's disregard the original polynomial. Let's say P of x again, though. Let's say P of x does equal some x to the 8th, dot, dot, dot. And let's say right now, I don't know anything. I don't know a single thing about this polynomial. I haven't used Descartes' rule of signs or anything yet. How many possible real zeros could I have? Just look at just x to the 8th. Possible real zeros, based on what we just said, could be that number, or what? Can I have 7? No, because if I have 7, 2 complex numbers need to show up. They show up as pairs. So it would actually be if I had 7 zeros, then when my complex zeros show up as pairs, that would give me a total of 9 zeros, which doesn't match that 8, right? So we have 8, 6, 4, 2, or 0. Does that make sense right now? Okay. That is if I don't know anything about Descartes' rule of sign. The question in your homework is going to look like this. It says real positive zeros, and this is possible. I'll say possible real positive zeros. Let's say, and that's based off the sign changes, right? So let's say we go through our sign changes, and we get 6 sign changes. So 6 could be 4, could be 2, could be 0, right? Okay. Let's say it asks for real negative zeros, the possible ones there. Let's say for some reason you just find out that there are 0. Maybe there are no, when you do P of negative X, there are no sign changes. Okay. Now that you know that information from Descartes' rule, okay, this guarantees that this row here of possible real zeros is going to change. Because you now know you can have 6 positive real zeros, but you're going to have no negative zeros. Does that make sense? So how many, if I pair that with that, what's the maximum number of possible real zeros I have? 6. So I'm going to cross that. That 8 doesn't belong now, because now I know more information. Does that make sense? When you learn more information, you can be more specific about that row. So that 8 doesn't belong. So what that would tell me is that, yes, I'm going to have a total of 8 factors eventually, but only 6 of them may have real zeros. The other 2 are going to be, they're going to have imaginary values. They're going to have I. Does that make sense? Okay. So just be careful. Somebody in the last class was saying, well, you said when we look at this 8, that I could have 8, 6, 4, 2, or 0. And that is true if I don't know anything about Descartes' rule of signs yet. If I know stuff about that, then that changes. Okay. My knowledge about that should change. Is that cool? Can we do that? Yeah. Okay. Let's go to, let's see here, where did it go? I had it typed in, but I'll try it now. Let's do an example here. So try to put everything we've learned so far in this chapter together on this problem. All right, so I'm going to ask you to come up with, well, let's do this first. Let's just start at the beginning of the chapter. At the beginning of the chapter, we were talking about end behavior. So if I look at this x to the 4th, the end behavior should be modeled like that, right? Okay. I've got my negative 18 here. That's my constant. So if my x is 0, if that goes away, that goes away, that goes away, that goes away, when x is 0, y, or p of x, is negative 18, right? So I got my y-intercept. Okay. Now we want to go through and see if we can find our zeros. So the way we're going to find those zeros is through using P over Q. Okay. Well, when I use P over Q here, let's find those first. The order that you do this stuff is really not all that important. We're going to use those two theorems, the bounds theorem and the Descartes' rule of signs. If you want to do that before you find P over Q or after you find your P over Q's, it doesn't matter. But my P values are factors of 18, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18, right? Q values, plus or minus 1, plus or minus 2. So your final P over Q list, P over Q should be plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 2 over 1. Now, if I go plus or minus 2 over 2, do I already have that in my list? Yeah. I'm going to go plus or minus 3 over 1, plus or minus 3 over 2, plus or minus 6 over 1, plus or minus 6 over 2. If I go 6 over 2, do I already have that in my list? Yep, so I'm not going to write it. Plus or minus 9 over 1, plus or minus 9 over 2, plus or minus 18 over 1, and then plus or minus 18 over 2, which I've already got in my list. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 different P over Qs that we can check there, right? Okay. The next thing I want to do is figure out the rule of signs. So Descartes' rule, okay, says to look at P of X, and you're going to figure out the possible positive real zeros and the possible negative real zeros. So I look for sign changes, right? So coming up here, this is a plus to a minus. There's 1. Minus to minus, minus to plus, and plus to minus, right? So I have 3 variations in sign. So I could have 3 possible real zeros, or how many more? What do I do next? If I have 3, I could have also just 1. Remove 2 from it, right? And then I stop. So if I subtract 2 more from that, I get negative 1, right? And remember, this is talking about a quantity, an amount that I could have. Doesn't make sense to have negative 1 zeros. Okay? So now I got possible negative zeros. And here's what I'm talking about, maybe doing some stuff in your head a little bit. If I want to find P of negative X, okay, negative X to the 4th is positive, right? So I was going to say 2X to the 4th. Negative X raised to the 3rd is negative. Multiplied by the negative out front will be a positive 3X to the 3rd, right? Negative X squared is positive times the negative out front is negative. It's going to be negative 33X and then minus 18, right? So I didn't have to write the line where it's like 2 negative X to a 4th plus 3 negative X to a 3rd. You can if you want, but I think hopefully we're a little bit beyond that. So now I'll check my variations in sign. Positive, positive, that don't count. Positive, negative, there's 1. Negative to negative, negative to negative. So I only have 1 possible negative zero. Does that make sense? Okay. Now if I wanted total possible real zeros, I could have 3 paired with 1, so I could have 4. I could have 1 paired with 1, so I could have 2. Or that's it. Okay? Does that make sense? We all right with that? Yeah. Okay. Now, here's the thing. Now we're going to start doing division. Now, here, I'm just going to start with synthetic division. So 2, -3, -14, 33, and -18. All right? And we're just going to start working through our P over Q list with that. Okay? Now, when we do that, let's say that we try let's see here. You can systematically just, this is what I do. I just start with 1, try 1. If it works, great. If not, I go to -1. Okay, and I go kind of in order of my list, because I think it's important to make sure I realize which ones I've done and which ones I have not done. Does that make sense? And I keep track easy that way. But let's say that we try. Let's just randomly choose one up there. Let's put 3 in. Okay? And here's the thing. You know nothing about this graph yet, right? You know absolutely nothing in regards to zeros, so you don't know which one of those, each one of those is as likely to occur right now as any other one. Does that make sense? So your probability of picking one and it working is as good as picking any other one and it working. So 3 has a highest probability as any of them up there. So let's see if what we do with 3 yields any information. So if I do 3, I'm going to bring my 2 down, multiply, gives me 6, add, gives me 3, multiply, gives me 9, -5, multiply, -15, add that down, so it's at 18, multiply gives me 54, okay, so that gives me what, 36, okay. Did it give me a 0? Nope, okay. So 3 is not a 0, because the remainder is not 0, okay. Something to think about, this was positive. This was positive out in front. So when positive, I'm going to try to look at my quotient line, and my hope is that all of these are positive. And there's one throwing it off, right? And the reason I would look for all those to be positive is the upper and lower bound theorem that we talked about yesterday said if you divide by a positive number and your quotient line has no negative entry, then that thing you divided by is an upper bound, meaning there are no zeros above that. Does that make sense? Okay. So 3, through this multiplication here, doesn't lead me to that information. Okay? Let's try 9 would be fine, but let's try 6. Let's try 6. Now, what kind of stinks for you guys is that you have to rewrite all that, right? So much work for one only problem. I know. So we're going to talk about that. So I'm going to bring my 2 down. Gives me 12. Bring my 9 down. Gives me 9 times 6. 54. Okay. Add that down. Gives me 40. That gives me 240. So that's going to be, what, 273. Now, I don't know what that product is going to be, but is that going to be bigger than -18? So that's going to be a pretty large number. Is that still going to be positive? It's not going to be a 0, right? Okay. Now, here's the thing. That was a positive 6, right? And here's the argument. This is going to help a little bit with Blaise said this is just a long process just for one problem. This should help that process a little bit. This was a positive number I divided by, right? What do you notice about your quotient and remainder row? All positive. So what's that tell me about 6? It's an upper bound. Meaning that when I go back up to my list, positive 9 just got kicked out. Okay? positive 18 just got kicked out. That make sense? Okay. I would argue maybe that if you would have tried, so we tried 3 and it didn't give me an upper bound, which all our zeros, if we graph this, all of our zeros are to the right of 3. To the left of 3. So even though the algebra doesn't show it as an upper bound, we do see that graphically that does exist as a kind of a limiter or a graph. But if you would have tried like 9/2, I would think that 9/2 would probably give you a remainder of all positive numbers, and then that would have kicked out obviously 9/2. It would have kicked out the 9. It would have kicked out the 6, and it would have kicked out the 18. So it would have kicked out one more value for us. Okay. But that's the idea. And now, if you're not paying attention, if you can do these, you can absolutely do this work without knowledge of Descartes' rule sign and the upper and lower bound theorem. But you're going to be very inefficient in doing them if you're not paying attention to that stuff. Does that make sense? So in the past, I've had people not pay attention to that. They get the right answer, but they don't get through the test. They don't get through all the questions on the quiz because they are trying every one of these, and it might not be until maybe right there in the last 3 or 4 that you find the actual zeros. Does that make sense? Okay. Especially maybe if you write your list a little bit differently than we wrote here and the way that we ordered them. So that's just something to think about. All right. So I'm not going to try those. Now, here's the thing. Now, so Blaze is saying, oh, this is a pain in the butt. And I agree. Okay. And we cannot, and this is the reason I'm doing this, we have to be able to have that skill. You have to be able to understand how to do synthetic division and what we're trying to use when we divide and what that means when we get a 0 back. Okay? And what it means when we get a remainder of 0, what our quotient line actually represents. Because if you don't, the next section and the next problem that we do today is going to be impossible for us to deal with. Okay? So this process is not something we can completely circumvent with our technology, but we can use our technology to help us. Okay? If I graph this polynomial, do you know your zeros right now when I graph that polynomial? Yes. Yes. Okay? You know for certain what will divide this. What 0 will divide this polynomial? Let's just start from left to right. -3. -3. Okay. Huh?
I thought you said what divided instead of what divided.
Oh, I'm sorry. So I'm going to start synthetic division with -3. It gets the ball rolling. Okay, look at the graph and knowing what that 0 is. Okay, and this is the type of thing I want to ask you on a test or quiz. Okay, I might give you one of these where I say, okay, do the entire thing, factor all the way down. But then another one I might say, okay, here is the polynomial that I want. I want you to show me the word. I want you to tell me what the quotient is after you divide by the first factor, the first 0. Okay? So I'm going to ask you to do this somehow. Bring that 2 down. Gives me -6. That gives me -9. That's going to give me 27. So it's at 13. And that gives me -39. That gives me -6. That gives me +18, right? Now, I know this should work, and this is how you got to guarantee whether you've done all this right. We knew graphically that was going to be an x-intercept, right? That was going to be a 0. So what should this number right here always turn out to be? 0. Okay? Now, here's my thought. You divided by a negative, and now your quotient row is going positive, negative, and then view this how you want. I'm going to view it as a positive. Does that make sense? That tells me that -3 is indeed a lower bound, not only a 0, but a lower bound. Does that make sense? Okay. Now, why do I need to know that? Well, and be able to do that. I want this was x to the 4th. This is now x to the 3rd, right? We've talked about that. Eventually, we talked earlier in the period where we could have like a 4th degree polynomial and only 2 real zeros. So the other two zeros might be imaginary. In order to kind of plug out and figure out what those imaginary zeros are, we have to be able to know what that quotient line looks like. Okay? So right now I've got we start with a quartic, a fourth degree. We divide it out by a linear factor of x plus 3. That's what this is going to give me, right? So if this is a 0, then x plus 3 is the factor. Okay? I want to keep going because now I know I've got x plus 3 at this stage. This thing, this p of x is x plus 3 times x cubed minus 9x squared plus 13x minus 6. That is what that original polynomial looks like when I divide by x plus 3. Is it okay? Let's go further. Looking back at our picture, what's another 0? 1, right? So I'm going to try 1. Put that in a box. I don't like the repeat, so I'm just going to go straight from this remaining row here. And use that as my new starting row. So bring my 2 down. 2 times 1 gives me 2. Add that, gives me negative 7. So that gives me 6 then. 6. And that gives me 0. Is that okay? Now, what that means then, okay, do these, now think about it, here's my question, because this is, I'm looking at this row, and does it go positive, negative, positive, negative? Okay, but why? Why can't I not apply the lower bound theorem?
Oh, because negative 3 was the lower bound.
Yes. Well, negative 3 was the lower bound, and it's because it was a negative, right? The lower bound theorem says if you divide by a negative, you're looking for alternating signs. Am I dividing by a negative here?
Nope.
No. So this alternating signs doesn't really mean anything to me because the if part of our theorem, the hypothesis, is not met in this situation. Okay? So we're not just looking at the conclusion. We have to make sure the if part is met. So this is, it's a factor. X minus 1 is a factor, but obviously it's not a lower bound because we've already found our lower bound, right? Okay. So what does that tell me right now? That tells me that x plus 3 times x minus 1, now this would be x to the what? Second. So 2x squared minus 7x plus 6 would be what my original polynomial looks like. Okay. Now, eventually, if we only had 2 real zeros, which were negative 3 and positive 1, and we wanted to find all of our complex zeros, okay, so the ones that incorporate like imaginary numbers and all that kind of stuff, we have the ability to factor that. We can use a quadratic formula with that. Does that make sense? Okay. So that's kind of what the next question we're going to get at target. But if we look back at our graph, okay, our graph still intersects the x-axis 2 more times, right?
Yeah.
Okay. If these produce complex zeros, our graph would not be intersecting our x-axis 2 more times. Okay. So we keep going. Okay. Now you can do one of two things. If I have my graph, I'm going to do synthetic division. If I don't have my graph, I'm not going to go back up to my list of P over Qs and try them because right now I've maybe dwindled my list down to maybe, I don't know, 8 or 9 remaining P over Qs that I have to use. I don't want to check those. Okay? If I've got something that's quadratic, do you have the ability, do we spend an entire month and a half factoring quadratics at the beginning of the year?
Yeah.
Yeah. So at this stage, and we'll do this, but at that stage, if you don't have your graph, I think you could take that and factor it pretty efficiently. Okay? But you have your graph, so let's cheat.
Are you going to let us graph it on the grade?
We'll talk about it. So I know that we already tried 1, right? There's 3 halves. I don't want to try 3 halves. I don't want to deal with fractions, so I'm going to try 2. Okay? So we'll put 2 in. Bring my 2 down. Multiply gives me 4. Add gives me negative 3. Multiply gives me negative 6. Gives me a 0 there, right? This was x to the second, so this is x to the first. This would have been x minus 2 as a factor, right? Is that a linear factor right now? Yeah. So what's going on here then is my first factor was x plus 3. My second one was x minus 1. My third one is x minus 2. And my fourth linear factor is 2x minus 3, which is the 3 halves as a 0, which is what the graph was showing me, right? Okay, now, that's fine, that works. That is the factored version of that original polynomial right there. Okay, now we could have gone through all this additional work here and done everything by hand without looking at our graph, but we'd probably still be looking for our first or second 0. Does that make sense? Okay, so my hopes are, in regards to efficiency, we use our graphs. Now, at that stage where I said we had this, could I have done this? Instead of going with the synthetic division further, okay, could I have said, okay, I'm going to use the AC method, so I get 12, negative 3 and negative 4 multiply together give me 12, and I have to give me negative 7. So now I'm going to go 2x squared minus 4x minus 3x plus 6. Group those two. What can come out of these two? 2x leaves me x minus 2. What can come out of these two? Negative 3 is leaving me x minus 2. Does that give me 2x minus 3 and x minus 2? Is that what that is right there? Okay, so synthetic division for that AC method there would help me. So what I'm trying to say here is that we've got a lot of different techniques. It's kind of like a hodgepodge of techniques, and you hopefully have the freedom then to pick the ones that make sense to you. Can I keep going with synthetic division? Absolutely. But if I get to x squared, maybe I've got more efficient way, especially if I don't have my graph. Okay? If you don't have the graph, I'm restricting you from using the graph, whatever. You get down to something that's quadratic. Do not spend time using synthetic division on it. You're going to waste your time. Okay?
I don't know why you always ignore me, dude.
I always answer your questions that are valid.
Do we have a quiz tomorrow?
Have we had one in a while?
Yeah, we just had one like a week ago.
We did?
Like 2 weeks ago.
We did?
Yeah, for sure.
All right, let's do this one.
That doesn't answer my question, that you said.
I think it is. So look at this one. We've got, let's go with rule of signs here real quick. Okay? So positive real zeros. There's only one sign change, right? Okay. Then if we go to negative real zeros, okay, so this would still be x to the fourth, so p of negative x, so it'll be x to the fourth plus x cubed minus 5x squared plus x minus 6, right? So one sign change, two sign changes, three sign changes, right? So we have 3 or 1. Okay? What I'm going to tell you, because I know a little bit about this graph already, you're going to have one positive real zero, and you're going to have one negative real zero. So where are the other two zeros that make up that fourth power, fourth degree? They're kind of hidden, right? Make sense? Okay, so here's the thing. Here's what I want to do. Our P over Q, this isn't a bad list of P over Qs. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, right? If your leading term A sub n is 1, then your Qs are just 1, right? So then your list of P over Qs is just equal to your P value list, right? Does that make sense? If that's a 1. So I can trick those, okay? I think I've graphed this somewhere. I'm good. I didn't graph it. I don't think you're talking to me.
It was Blade's card.
Was it?
Yeah, I looked out in the hallway and it was Blade's card. I thought it was the one.
Yeah.
Thank you.
I mean, that's the consensus amongst us.
Okay, I don't know what that means.
All right, so we know, so looking at this, I know -2 and 3 are going to work. Does that make sense? I know those are going to be factors. Now, those are the only real zeros. That thing doesn't cross anymore, right? So I know it's a 4th degree polynomial, so I should have 4 linear factors, but I'm only getting 2 of those linear factors to produce real zeros. So how do I get the other 2? What are the other 2? Let's do this. Let's go. If I do synthetic division, we have 1, -1, -5, -1, and -6. And we know, looking at the graph again, we know that -2 is going to work, right? So I'm going to use synthetic division to go with -2. And this should model why we can't just use our calculator and circumvent the entire synthetic division process. When I bring down that 1, multiply, I get -2, so it gives me -3, that gives me 6, 1, -2, -3, +6, that should make sense, right? Okay. Upper lower bound theorem, this is alternating, positive, negative. That was a negative. That tells me don't check anything less than -2. Okay. So this is a lower bound, but it also means that x plus 2 was a factor. This was x to the 4th, so this is x to the 3rd, right? Now I also knew that 3 was going to work, so let's try 3. Bring down my 1, gives me 3 there, 0, 0, bring down my 1, gives me 3 there, 0, right? Okay, this was a positive number. These are all positive numbers, right, or non-negative. So that tells me that this was an upper bound, okay? But x minus 3 is a factor. Now, here's the thing. I can keep trying synthetic division with the remaining P over Q's of 1, 6, 2, -3, and -6, but none of them will work. None of them generate a 0. And the reason is because if this was x cubed, what is this thing here? X squared. So right now, my original polynomial is x plus 2, x minus 3, now times x squared plus 1. Okay, now here's the thing. Euler, okay, Leonhard Euler was working with that formula, that equation, x squared plus 1, and he knew there was no solution to that. But we wanted a solution. So what did we do? We created a solution. We developed I. Okay, so that's what we get. Does that make sense? We introduce a human invention that I is equal to the square root of a -1. Okay, so x squared plus 1 can still be broken down to linear factors. It's just now, if x is equal to I, what is the factor that I get? Yes, x minus I, and this one is x minus -I, which turns into x plus I. So now I got x plus 2, x minus 3. P of x, was it originally x to the 4th? Which told us we should have 4 of those, right? We should have 4 linear factors. 2 of them which are imaginary, right? Now, in order to find those imaginary, in order to find these, we call these complex zeros. In order to find those 2, you have to be able to do synthetic division to get that quadratic row. Does that make sense? Okay. Now, there are questions that we're going to see that might be outside the scope of this class. Let's say I started with a 6th degree, and I only had 2 real zeros. And that means I have 4 complex, right? That means this row here would be a 4th degree. Unless we use maybe like a U substitution or something like that, we're not going to be able to find all 4 of those complex zeros. We just don't have the ability to do that yet. I don't know about tomorrow yet. It is Friday, though. Middle of the month. Beware the Ides of November, Chuck.